Good morning and welcome to problem 6.27. In 6.27, we are asked to use the method of sections to determine the force in members BC, BF, and BF. I'm sorry, BC, BF, and BE, and then describe whether they're in compression or tension. I'll go ahead and mark where that section is. Notice that regardless of whether we use the left section or the right section, it will contain a support. So we are going to have to go through to calculate the reactions to the support at AX, AY, and DY. So that's kind of where I'm going to start anyway. So let me get pen color changed and away we will go. Well, certainly starting with AX would be really easy. Summation of the forces in the AX or the FX direction is equal to AX, which is equal to 0. There's only one force in the X direction. I'll go ahead and mark that down as 0. Let's see, we've got two unknown forces in the Y direction, so I'm going to go ahead and go to taking a moment. I'm going to take a moment about A. So let's see what we've got going on. AX and AY would not be players because they're pointed right at A. But the external force at joint B is a player, 4.5 kilonewtons, and it's 1.2 meters away. Continuing around, the next player is DY. And DY is 1.2, 1.2, 1.2, 3.6 meters away as its perpendicular distance from point A. And then finally, the 2 kilonewton external force at point E, which is 2.4 meters away. Grab and direction. So let's see, if we're rotating about point A and we're pushing down at B, that causes a clockwise rotation, which is negative. DY is going to cause a counterclockwise, which is positive, and the external force at E produces a clockwise rotation, which is negative. Solving for DY, we get 2.83 kilonewtons. I'll go ahead and fill that in real quick. 2.83 kilonewtons, which should allow us now to get the summation of the forces in the Y direction. So AY minus 4.5 kilonewtons plus 2.83 kilonewtons minus 2 kilonewtons is equal to 0. Therefore, AY is equal to, let's see what we've got here, negative 6.5 plus 2.83. So 3.67 kilonewtons. And I'll go ahead and fill that in. There we go. All right, I'm gonna pause the video while I get the board set up for the next part of the problem. Be right back. All right, well, welcome back. I've got the free body diagram set up. I'm going to use the right section of the truss. Again, it wouldn't really matter whether you use the left or the right. I just chose the right. Let's see what we've got going on here. So we're going to need to figure out the X and Y components for BE. So I'll do those down here. Let me change colors though first. There we go. All right, there's BE. So assuming that I have the correct direction, which is not necessarily safe, but I do know it won't matter. Then in the big scheme of things, the arithmetic will be what it is. So this is BE. This is the inverse tangent. 1.2 meters divided by 1.2 meters. This angle, the angle that we're looking at is this one here. So BF is 1.2 and FE is 1.2. And that equals 45 degrees. Meaning our y component is BE cosine 45 and our x component and the y component BE sine 45. That should set us up for success. What do we got going on here? So we've got 1, 2, 3 unknowns in the x direction, but we can certainly grab the y direction. So summation of forces in the y direction would be equal to negative BE sine 45 minus 2 kilonewtons plus 2.83 kilonewtons. So the negative 2 kilonewtons comes from the external force at point E, and the 2.83 kilonewtons is the calculated reaction at point D. Solving for B, therefore BE equals to 1.17 kilonewtons. Let me go ahead and fill that in. The fact that it's positive just means that I made a correct guess on the direction of BE, and that's going to be, so since the force is going into the pin, that is the reaction to the fact that the member is in compression. Okay, does that help us though? We still know FE or BE, so we can't really use forces in the x direction yet. So we're going to need to take a moment. I took my moment about point E. So let's see what we've got going on there. So moment about point E. FE and B are not players. The 2 kilonewtons not player. BC is a player, and BC has a perpendicular distance of 1.2 meters. And the 2.83 kilonewton reaction at DE is also a player at 1.2 millers. That equals 0, of course, because it's at equilibrium. All right, so let's see. Rotation about E, pushing BC to the right would cause a clockwise rotation, which is negative. And the reaction at D of 2.83 is pushing up, which would cause a counterclockwise, which is positive. Solving for BC, I get that BC is 2.83 kilonewtons. 2.83 kilonewtons. I've got that going into C. I've got a positive, so compression. Just means I made a correct guess again. And that, let me go ahead and add that up here. So this was 2.83. And B is 1.17 kilonewtons. Okay, there we go. All right. I think we have everything we need now for summation of forces in the x direction. So what we got going on there? So BC is in the x direction. BE cosine 45 is in the x direction. That's a negative, so is BC. And then FE is in the x direction. I guess I'm incorrect. Both of those are positive because FE is negative. Good catch. All right, filling in the stuff that we know. 2.83 kilonewtons for BC. We calculated that one. We did a good job on it too. 1.17 kilonewton times cosine 45 minus FE is equal to 0. Uh, 2.83 kilonewtons plus 1.17 kilonewton times cosine 45 is 3.66 kilonewtons minus FE is equal to 0. Therefore, Fe is equal to, you guessed it, 3.66 kilonewtons. I have that coming away. The reaction at joint E for Fe is coming away. That would be the reaction to Fe being in tension. All right. Hey, I hope you guys are having a great day. I'm going to take a couple minutes to get ready to videotape our next homework problem. See you in a little while.